Any questions? Is that a question, or you were thinking about a question? Or just wondering why the stuff's in front of you?
Is there a question on the quiz that was on the homework, which was like two pucks colliding at different angles? I forget the exact, like what you were trying to find, but two identical pucks collide in the air, on an air hockey table, and you're trying to find what is the velocity, magnitude, and direction of the second puck, given that the one puck was originally at rest. If the incoming puck was at a speed of 6 meters and scatters to an angle of 30 degrees.
All right, so first one's going 6 meters per second, hits, and
One
then
is-
goes off at
30 degrees.
30 degrees.
Yeah. What is the velocity, magnitude, and direction of the second puck?
I assume the pucks have the same mass.
Yeah.
The direction? Oh, I didn't talk about it with this group, okay. Well, this is gonna go off at some velocity. I know you didn't ask me to actually do the problem. Are you okay if I do it?
Go for it.
So this has some V final, 6, no. Some, we'll call this mass puck 1 and puck 2. And they didn't give the final velocity of the first one, they just said 30 degrees.
Yeah, I don't think they give a final velocity. The only other thing they give you is you may use the result that theta 1 minus theta 2 equals 90 degrees.
All right, so that gives us the angle right here, 60 degrees. That was a really horrible writing, so let's see if I can redo that one. Ooh, not all of it. That's 60 degrees.
Okay.
Now, the situation in order for that to be 60 degrees is if the masses are the same and one of them is at rest, then they'll go at 90 degree angle to one another. That's V2 and that's V1. So it's a conservation of momentum problem. I know that the initial momentum equals the final momentum. And let's establish a convention here. I hat, J hat. So what's the initial momentum?
6 meters per second. For mass 1.
What's the momentum?
Oh. Well, I don't think we know the mass.
Therefore,
We don't know. Or I guess if they're the same one, or the same mass, we could just make up a number.
yeah, all right, so that is one option, to make it up a number, make up a 1, if you want, or you could just make it 6m meters per second. Do you want to make up 1 or just show that it cancels out at some point?
We can just cancel it out.
Okay, so we start out with, in the I hat direction, and we'll have J hat direction. In the I hat direction, it is 6m before, and it's got to be equal to that afterwards. Well, I've got two different bits here. I got V1 m cosine 30 degrees plus V2 m cosine of 60 degrees. It's momentum before equals momentum afterwards horizontally. Now we do the vertical. Oh, somebody tell me the vertical equation.
0 equals 0.
That is a true statement. I cannot fault that. Doesn't really help us solve anything. But let's see if we can make it more specific to this problem as opposed to a universal truth. Although there is a proof to show that 0 equals 1, but that's a different story.
you wanna assign 60?
What goes in between them? Have somebody say it. Because down is negative, so it's technically this j hat plus this negative of j hat. We have two equations, two unknowns. Well, actually, we have m in every equation. So at the suggestion of Jack, we get rid of all the m's. Over here, we divide everything by m. And 0 divided by m, of course, is 0, despite what some students have told me in the past. Two equations, two unknowns. It's now, what technique do you want to use? So we have 6 is equal to square root of 3 over 2 v1 plus 1/2 v2. And 0 is equal to 1/2 v1 minus square root of 3 over 2 v2. How do you want to solve it? Substitution, solve simultaneously, matrices, determinants, Cramer's rule.
We need to do substitution.
Substitution. All right. So I multiply everything by 2 here. Surely one of these will work. Multiply everything by 2. Those 2's go away. Bring this over to the other side, so v1 is equal to the square root of 3 times v2. Pop that in up there, I get 6 is equal to the square root of 3 over 2 times the square root of 3 v2 plus 1/2 v2. So this is 3/2 v2 plus 1/2 v2, which is 2 v2. So v2 equals 3 meters per second. Plug into here. v1 is 3 radical 3 meters per second, which is so around 5.2 meters per second.
How'd you get 3 meters per second from?
All right, so when I multiply that, I get 3/2 plus 1/2 is 4/2, otherwise known as 2.
Oh, right.
And so divide both sides by 2.
Oh. So, I don't know, my brain is like 2 divided by 6. I was like, why am I dividing by 6?
I will agree 2 divided by 6 is not 3.
Indeed, so.
Two great truths. 2 divided by 6 is not 3. 0 equals 0.
5.196.
So I was completely wrong.
No, it asks for the magnitude and direction. So it can go either both ways? Because we have the 2 directions of V1, so it'd go the 30 degrees up.
So assuming that that's positive 30 degrees, this would be negative 60 degrees. So in polar notation, V2 was 3 meters per second, negative 60 degrees, or 300 degrees, or five pi over 3. So that's V2, the velocity, and then V1, 30 degrees, and 5.19 meters per second.
Okay.
The big thing is that these are opposite sides. But the general convention that I will accept without you having to define it is, no, they're opposite sides. They have to, The difference has to be 90 degrees, however you do it.
Can you show, method 3 with this problem?
No. Oh, well,
It doesn't work here?
it does. It's not as simple as it is for a one-dimensional problem.
Okay.
But you would find the center of, if you're doing the method 3 with this, you're trying to figure out where is the zero momentum frame. So you do that the same way as you did before. And then after the collision, in the zero momentum frame, it is in 2 dimensions, but they're gonna be going in opposite directions of one another. So it's not a simple flipping of sign. We would have to convert this 30 degrees into what is it in the zero momentum frame. And then figure out what that one is, because it'd be the opposite, and then shift it back.
Yeah.
I typically don't do that with 151.
Okay.
251 I can torture with that, but 151 I generally do.
Yes.
But if you would like, I'll make sure I put a problem like that on the test.
Please no.
Okay, not on your test.
Not on this.
Are you okay with Mike not going over some
Yeah.
the problem? Okay. Other
As long
questions?
as long as it's not gonna be on the test. Is there going to be a 2-dimensional problem on the quiz?
Maybe.
Maybe, okay.
I mean, I gave you, I think, 7 problems. It's gonna be 2 very, very similar to 2 of those.
Okay.
I actually, I know the first one is not. All right. I'll erase it after I figure it out. Oh, that's right. Calculators. I'm putting them face down for no particular reason. If you're doing a last minute thing.